Hello everyone. Today we will be deriving spherical coordinates as per the physics convention. I said physics convention because maths and physics people disagree on which angle to call theta and which angle to call phi. And since I come from a physics background, I will be doing the physics convention. So if you have any geometry textbook, it is very easy to just look up the conversions from Cartesian to polar coordinates and save time. But it is always nice to know how to derive them. First, we will be looking at Cartesian coordinate system. So we consider a point in the xyz space. The distance from the selected origin to this point is called the position vector, and this position vector is given by r is equal to xi cap plus yj cap plus zk cap, and the magnitude of this position vector is given by r is equal to under root x square plus y square plus z square. Now the other quantities which we need to look at are theta here, which is the angle made by the z axis with respect to the r vector. So here we can if we go by the maths convention, they call it phi and this angle they call theta. So according to physics convention, we will call this angle theta, and if we project this r vector on the xy plane, the angle that the x-axis makes with this projection is called angle phi. Let us call this line x prime. And now if you apply a little bit of geometry, you know if this angle is theta, then this angle will also be theta, and sine of this angle will be sine theta, which is opposite upon hypotenuse, which is equal to x prime by r. So we know x prime will be r sine theta. So let us replace this by r sine theta. R sine theta. Now if we drop a perpendicular from this point to the x-axis, we get a triangle which looks like this. And if you observe, this is our x-axis and this is our y-axis. So let's call this x and this will be our y. So the cosine of this angle phi will be cos phi, which is x by r sine theta. So we have our first conversion, which is x is equal to r sine theta cos phi. So similarly, if we take the sine of this angle phi, we get sine phi, which is y by r sine theta. So we have y is equal to r sine theta sine phi. So this is our second conversion from Cartesian to polar coordinates. And now if we take this triangle, we know cos of theta will be z, let's call this z, by r, which is adjacent upon hypotenuse. So cos of theta will be z by r. So you know z will be r cos theta. So now we have our three conversions from Cartesian to polar coordinate systems. I hope this video was helpful, and now I will see you in the next one.